Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We started our discussion with Principles of Mathematical Induction, right? What did we discuss? We discussed about different themes and different problems of mathematical induction, right? The only thing is we'll have three basic steps. That is step 1 in which we are going to substitute it as n is equal to 1, and in the second step we are going to assume that a given statement is true for n equal to k, and in the next step we will prove that p of n is true for n equal to k plus 1. Is it right? Fine. Let us do few more problems on this principle. Okay, shall we start? See here. The question given here, it is he is asking us to prove 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 and so on up to nth term is equal to n into n plus 1, n plus 2 and n plus 3 by 4. Is it right? What is the difference between the previous questions and this question? Tell me. That is, in the previous questions we used to have either one term or two terms, or else two terms in the denominator. Here we have three terms in the numerator itself, right? That is one thing. And second most thing is we don't have nth term. That is, we have to find the nth term here. Yes or no? Fine. Shall we do? Fine. What is the first step we have to do now? We have to separate this first terms. That is 1, 2, 3 and so on for first term, and next 2, 3, 4 for next, and the next 3, 4, 5. 3, 4, 5. This is for third set. Yes or no? For the first set, first term is 1. Common difference is also 1. 2 minus 1 is 1, right? Yes. And for the second set, first term is 2, common difference is 1. For the third set, first term is 3, common difference is 1. Okay. What's the formula for n? A plus n minus 1 into d. However, you people know, let me directly substitute it. A plus n minus 1 into d. Here, an is a plus n minus 1 into d. Here an is 3 plus n minus 1 into 1. Is it right? Just let us multiply 1 plus n minus 1, 1 get cancelled. This will be an. Here an is 2 plus n minus 1, that is n plus 1. Here 3 plus n minus 1, that is n plus 2. Is it fine? Then what is my final nth term? Tell me. Final nth term is n into n plus 1 into n plus 2. Is it right? Now tell me what will be my next step. We will assume let p of n be, what is it? 1, 2, 3 plus 2, 3, 4 plus 3, 4, 5 and so on up to n into n plus 1, n plus 2, that is equal to n into n plus 1, n plus 2 and n plus 3 by 4. Is it okay? What will be my first step now? Step 1 will be put n is equal to 1. Yes. Then what is my LHS? LHS will be 1 into 1 plus 1 into 1 plus 2. That is 1 into 1 plus 1 into 1 plus 2. That is 2 into 3, that is equal to 6. Is it right? Now let us do the same thing on the right hand side. For right hand side, 1 into 1 plus 1, 1 plus 2, 1 plus 3 divided by 4, that is equal to 2 into 3 into 4 divided by 4. 4 will get cancelled. 2 3s are 6. Yes. Now LHS is equal to RHS. Therefore, P of n is true for n is equal to 1. Is it right? Now tell me what is our next step? Our next step will be assumption. What is it? Step 2 is assume P of n is true for n is equal to k. Is it right? What is that we have to do now? Instead of n, we have to substitute it as k. That is 1, 2, 3, 2, 3, 4, 1 into 2 into 3 plus 2 into 3 into 4 and so on up to k into k plus 1 into k plus 2 is equal to k into k plus 1, k plus 2 into k plus 3 divided by 4. Is it right? Fine. Again, we know that this will be my statement 1, this will be my statement 2. Is it right? What will be my third step? That is, we have to prove that we show that P of n is true for n is equal to k plus 1. Yes, that is, we have to substitute the value of k plus 1. How do we do? The only thing is we will write this as it is, and the next substitute k plus 1 instead of this k. Yes, see here, that is k into k plus 1 into k plus 2 into k plus 3 divided by 4 plus, instead of k I have to substitute it as k plus 1. Here also k plus 1 plus 1, that will be k plus 2. Here k plus 1 plus 2, that will be k plus 3. Is it right? Is it clear? Fine. Now let us take 4 as LCM. Okay. What will be left here? K into k plus 1 into k plus 2 into k plus 3. Plus here 4 will be coming this side. The left out is k plus 1, k plus 2 and k plus 3. Yes, let us take everything whatever it is common in both the terms. K plus 1 is common, k plus 2 is common, k plus 3 is also common. This will become k plus 1 into k plus 2 into k plus 3 into, what are the terms left? K is left here, 4 is left here by 4. Is it right? Is it not the same as it is in the question? Yes, right. Now let us write it in the simple form. K plus 1 into k plus 1 plus 1 into k plus 1 plus 2 into k plus 1 plus 3 whole divided by 4. Is it right? Fine. This is n, n, n and n. Therefore, P of n is true for n is equal to k plus 1. This will be my third statement. Therefore, from 1, 2, 3, P of n is true for all n belongs to n. Is it right? Is it not easy to solve? What is that we have to remember here? This is the only thing we have to remember. That is, there are 3 sets of progressions where the whole nth term will be multiplication of 3 nth terms. Yes, this is 1 nth term, this is 1 nth term. At last, we will multiply those 3 nth terms. Yes or no? Is it clear? Shall we move on to the next problem? The next question here given is 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 and so on up to n terms. That is equal to n by 24 and 2n square plus rn plus 13. Yes or no? Now if we observe, what is the nth term here? Nth term is 1 cube plus 2 cube plus 3 cube and so on up to n cube divided by 1 plus 3 plus 5 and so on up to some n terms. Yes or no? What is that we have to do? In the numerator, it will be sum of cubes of first n natural numbers. The formula will be n square into n plus 1 whole square divided by 4. Isn't it? And in the denominator 1, 3, 5 and so on up to n terms. That is, let me write it separately. An is a plus n minus 1 into what is d? 2. That is 1 plus 2n minus 2. That is 2n minus 1. In the denominator, we will get it as 2n minus 1. Is it right? Did you understand? Fine. This an, this is the sum of n terms and this is nth term. Yes or no? Is it clear? Then what will be my sum of n terms? N by 2 into 2a plus n minus 1 into d. That is n by 2 into 2 plus 2n minus 2. 2 will get cancelled. N by 2 into 2n. 2 will get cancelled. This is n square. Right? Is it clear? This is kind of rough. This both will get cancelled. Nth term is n plus 1 whole square by 4. Fine. Now just write it. Therefore, let P of n be 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on up to n plus 1 whole square by 4, that is equal to n by 24 into 2n square plus 9n plus 13. Okay. Now what is the next step now? That is, step 1 will be put n is equal to 1. Yes. Let us substitute it here. LHS will be 1 plus 1 whole square by 4, that is 2 square is 4 by 4, that is equal to 1. Yes. What about RHS? RHS will be 1 by 24 into 2 plus 9 plus 13. Okay. 13 plus 9, 22. 22 plus 2 is 24 by 24, that is equal to 1. Therefore, P of n is true for n is equal to 1. Isn't it? Fine. What will be my next step? Step 2 will be assume P of n is true for n is equal to k. What is my P of k? Tell me now. Isn't it? The only same topics will be repeating, that is the same steps will be repeating all the time. Fine. 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on up to k plus 1 whole square by 4 equal to k by 24 into 2k square plus 9k plus 13. Is it fine? Did you understand? Clear. And what will be my next step? Step 3 will be, now we show that P of n is true for n is equal to k plus 1. Is it right? Now let us directly write it. P of k plus 1 will be, as if we have did in the previous thing, we are going to write this as it is, that is k by 24 into 2k square plus 9k plus 13 plus we are going to substitute k plus 1 here. K plus 1 is k plus 2 whole square by 4. Is it fine? Now let us multiply, or let us take LCM. 24 into here k into 2k square plus 9k plus 13. Here 6 will come in the numerator, this will become k square plus 4k plus 4. Is it fine? Now let us write it completely. Let us write that is equal to k into 2k square is 2k cube plus 9k square plus 13k plus 6k square. 6 4s are 24k plus 6 4s are 24 divided by 24. Is it fine? Let us write it now. 2k cube plus 9k square plus 16k square is 15k square. 13k plus 24k is 24. 13 is 37k plus 24 divided by 24. Is it right? Again, what is the previous method we have used? That synthetic division method, right? What did we do? If I add odd terms, that is 2 plus 37, 39, and the next even terms 15 plus 24, 39, we are getting both as same, right? Therefore, minus 1 is one of the factor for it. Okay, let us write the coefficients. 2, 15, 37 and 24. Minus 1 is a factor. 2 plus 0 is 2. 2 into minus 1 is minus 2. 15 minus 2 is 13. Minus 13. Here it is 24. 24 into minus 1 is 24. This is 0. Therefore, my equation becomes as 2k square plus 13k plus 24 into k plus 1. That will be, let us write it here, that is equal to k plus 1 into 2k square plus 13k plus 24 divided by 24. Is it right? If I check here, n is equal to k plus 1, just we got it. Then what about the second term 2n square plus 3n plus 13, where n should be replaced by k plus 1. We can directly write without simplifying also. Okay, let us simplify a bit. Okay, here it is 2n square, that is it should be in the form of 2 into k plus 1 whole square. That will be k plus 1 will be fixed into 2 into k square plus 2k plus 1. Right? What are the terms left? 2 2s are 4k. Fine. Out of 13k, 4k is left. How many k's are left? 9k. 9 or how many? 9k, right? Fine. 9 into k plus 1. If I take constant, 2 ones are 2, 9 ones are 9, 9 plus 2 is 11. 11. In 24, if I remove 11, how much do I get? In 24, if I remove 11, I get it as 13. Yes, right? This is plus 13. Therefore, divided by 24. Is it not same as this? Yes, right? Fine. Therefore, P of n is true for n is equal to k plus 1. This is my third statement. Therefore, from first 2 and 3, P of n is true for all n belongs to n. Is it right? Fine. The only thing what we have to remember in this question, that is finding the nth term. Here, moreover, using the formula of nth term, we use the formula of sum of n terms. In the numerator, we have it as sum of square cubes of first n natural numbers. Fine. Is it clear? Shall we do one more problem? Let's do. Look at this question. There is also the same kind of question which we have solved in the previous questions, right? If you observe here, the question is in the form of 1 square plus 1 square plus 2 square and so on up to 1 square plus 3 square and so on up to nth term, right? Now tell me what will be my nth term? My nth term will be 1 square plus 2 square plus 3 square and so on up to n square. Sum of these all terms, that is nothing but sum of squares of first n natural numbers, n plus n into n plus 1, 2n plus 1 by 6. This is my sum of squares of first n natural numbers, right? Now let us write it directly. Let P of n be 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on up to n into n plus 1, 2n plus 1 by 6, that is equal to n into n plus 1 whole square into n plus 2 divided by 12. Is it fine? And the first step, what is it? Step 1 will be put n is equal to 1. Right? Now what to do? What is LHS? LHS is 1 into 1 plus 1, 2 plus 1 by 6, that is 2 into 3 by 6, that is 6 by 6, that is equal to 1. Yes? And what is next? RHS is 1 into 1 plus 1 whole square into 1 plus 2 divided by 12. That is 1 into 2 square is 4. 1 plus 2 is 3 by 12. 4 3s is 12 by 12, that is 1. Isn't it? Both are equal, right? Therefore, P of n is true for n is equal to 1. Yes? Similarly, step 2. Assume P of n is true for n is equal to k. Yes? That is, P of k will be 1 square plus 1 square plus 2 square and so on up to k into k plus 1, 2k plus 1 by 6, that is equal to the right thing, that is k into k plus 1 whole square into k plus 2 divided by 12. Is it right? Then what is my third step? Third step will be, now we show that P of n is true for n is equal to k plus 1. Okay. Now let us substitute it in that. That is, P of k plus 1 is we will write this kth term as it is. Yes, that is k into k plus 1 whole square into k plus 2 divided by 12 plus we are going to substitute k plus 1 instead of this k, right? That is k plus 1 into k plus 1 plus 1 is k plus 2 into 2k plus 1, 2k plus 2 plus 1, that is 3 whole divided by 6. Is it fine? Now what is the LCM between 12 and 6? That is 12. Let us write it as k into k plus 1 whole square into k plus 2 plus 2 into k plus 1, k plus 2, 2k plus 3. Is it okay? Okay, now let us simplify it. K plus 1, k plus 2. Can I take it as common? Yes, right. That is k plus 1, k plus 2 is common term. Here k into k plus 1 is left. There 2 into 2k plus 3 is left, whole divided by 12. Is it fine? That will be k plus 1 into k plus 2 into k is k square plus k plus 4k plus 6 divided by 12. K plus 1, k plus 2 into k square plus k plus 4k is 5k plus 6 divided by 12. Okay, now we have to factorize this k square plus 5k plus 6. What are the factors of 6? 2 3s are right, 2 plus 3 is 5. This can be written as k plus 1 into k plus 2 into k square plus 3k plus 2k plus 6 whole divided by 12. Is it fine? That is equal to k plus 1 into k plus 2 into k plus 2 into, let us take k common from the first two terms, I will get it as k plus 3. If I take 2 common from next two terms, I will get it as k plus 3 whole divided by 12. That is equal to k plus 1 into k plus 2 into, here if I take k plus 3 common, I will be left with k plus 2 whole divided by 12. Right? Now let us write this as k plus 1 into k plus 1 plus 1 whole square into k plus 1 plus 2 divided by 12. Is it not the same as a given question? Yes, right? Fine. Therefore, P of n is true for n is equal to k plus 1. From this, P of n is true for all n belongs to n. Is it right? Is it clear? Fine. By this problem, we have ended the chapter Mathematical Induction. Is it clear? What did we do in this chapter? The only thing we have to remember is these 3 steps. Right? The first step is substituting n equal to 1. Second step is assumption that P of n is true for n equal to k. And the third step, that is we have to prove that P of n is true for n equal to k plus 1. Is it right? Fine. Let us meet in the next session with the more problems of 1a. Thank you.